Now that we have the chain rule and we have the derivative of ln of x, we can now take the derivative of any exponential function. What we'll do is we'll take the derivative first, and then one example just showing you what you have to write down and what we don't have to write down. Now, there are many different ways of doing this. I'm going to do the technique we just write down, where we write down y equals, and then we have to find y prime. That's the goal. Now, the problem with this is that stupid x is up in the exponent. Well, we can get that x down by taking the ln of both sides. So I get the ln of y equals, I'm going to bring the x down. This is x times the ln of a. And then what I want to do is take the derivative of both sides. Like that. Now, believe it or not, the derivative of the right-hand side is easier. Because a was a constant, the ln of a is a constant. Right? So the right-hand side just looks like a constant times x. That's a linear function. The derivative of a linear function is just the number that's next to x. So all I get here is the ln of a. Like that. That was the easy side. The left-hand side reads the ln of blob. Right? The derivative ln of blob, we just saw, is 1 over blob times the derivative of the blob. Remember the goal, once we wrote down y equals a to the x, was to find y prime. I now have an equation that has y prime in it. Multiply both sides by y. I'm going to get y prime equals y times the ln of a. That is the derivative we're looking for. However, my original function didn't have a y in it, and my answer does. But we do know from this line right here that y is just a to the x. So what I get here is a to the x times the ln of a. You notice, by the way, that's still true if a is e, because the derivative of e to the x is e to the x times the ln of e, which is 1. It is better if you don't think of e to the x as being a special case of this, however. This whole thing here completely used the fact that we knew how to take the derivative of e to the x. So there's the formula for the derivative of any exponential function. Let's take the derivative of something that looks sort of complicated that involves it. Just so you see what we have to write down, what we don't have to write down. What I want here. How about if we have the derivative of, how about tangent squared, trying to practice everything we've learned up to this point, times a 5x squared. Yeah, that's it. Yeah. All right. Now remember, with derivatives, you start from the inside. The big picture is, I see a product, right? I know how to take the derivative of a product. It's the derivative of the first, and boy, that looks like it's going to be long, times the second, plus the derivative of the second, and that doesn't look so bad, times the first. What I like to do is put in the stuff where I don't have to take a derivative. This is the derivative of the first. That's a lot of work. I'm not going to do that. I'm just going to write a 5x squared like this. This is the derivative of the second. That's work. This is just the first. I can just copy that down. Now, I like to map out these things this way. I don't ever forget anything. I might get something wrong, but I won't forget anything. And you might want to do that if you're having trouble leaving stuff out. Now, what needs to go right here is the derivative of tangent squared 3x. However, remember, that's tangent of 3x quantity squared. So when we look at this, that's blob squared. The derivative of blob squared is just 2 blob. So I get 2 times the blob. Now I'm going to put a little orange box around my tangent 3x because that's my blob. That's what I'm supposed to multiply by the derivative of. Now, how do we take the derivative of tangent 3x? That's tangent blob. The derivative of tangent blob is secant squared blob. So I'm going to write secant squared blob, like that. And you can see my blob keeps getting smaller when we use the chain rule. Like this, yes. And now I want to multiply by the derivative of the blob, which is just 3, and we're all done with that part. Now we actually get to use the rule we just had. We have, oh boy, well, I can leave it as a, that's all right. The derivative of a to the blob is, according to the rule, is a to the blob ln of a. So I'm going to write down a to the blob times the ln of a. Now, by the way, I know that a is not a variable for two reasons. A is a letter at the beginning of the alphabet, and since you're in about 7th grade, they always use letters at the beginning of the alphabet for constants. So try to get in the habit when you see those letters to think they're constants. The other reason I know it's a constant is because they told me over here when they asked for the derivative that x was a variable. So telling me that x is the variable. So what I have here is a to the blob ln of a. Here's my blob. Then I need to multiply the derivative of, the root of 5x squared is just 10x. And that's all the work you have to show. You notice that here, when we took the derivative of the a to the blob part, we didn't have to go through the whole y equals thing again. We could just use the formula.